Alright, for this next lesson you are going to find some things that you are very familiar with. Constructing perpendicular lines is something that you've been doing since the beginning of the school year. Just formalize it today. So when you, just want to remind you what the definition of a perpendicular bisector is. It's the collection of all points that are equidistant from the endpoints of the segment that it passes through. So a point will lie on the perpendicular bisector if it's equidistant from the endpoints. That's the reverse or the converse of that statement. So we can either define the perpendicular bisector to be the collection of points, or we can say that a point is on that bisector if it satisfies the requirements of that collection of points. So there's an illustration of it here in the diagram that line CM would be a bisector of a perpendicular bisector of AB because AC and CB are equal and therefore equidistant from points A and B. Alright, so in exercise 1 we use a compass to try to construct a perpendicular bisector, and this is what has been known to us to this point as the football construction, just informally. But what's being shown here is that you don't need to use the same radius. It's more convenient to use the same radius when you're making your football construction, because then you could just make a continuous arc from A above and below the line and from B above and below the line. But this just illustrates that it will work no matter what, because what we're doing is employing that concept of it's the collection of points, right? So if I make a smaller arc, C will be closer to AB, but still equidistant from A and B. And if I make a bigger arc, point D will be farther from A and B, yet still equidistant from A and B. So satisfies the requirements, just a slightly different way of looking at it. So you can try that on your own and set your compass to whatever radius you like, more than half the distance between A and B, and make your arcs from both sides above the line, and then make a different radius below the line, and you can make the same similar construction. So in part C, why must points C and D lie on the perpendicular bisector? Draw it and verify that it's perpendicular. So when I have that perpendicular drawn, I can measure it. I can see that the two sides are the same. I can measure the angle with a protractor and show that they're 90 degrees. But I know that C and D will both be equidistant from A and B because the arcs that form CA and CB, which would be here and here, those are formed by the same radii, so they're going to be equal. And even though it's a different radius below the line, DA and DB will also be equal. So that justifies it. Alright, and so what you see in exercise 2 is your run-of-the-mill football construction. And because if I'm trying to construct a midpoint, basically what I need to do is bisect the line and mark where it was bisected, and that will be the midpoint. So this is the standard way that we've done it in the past. We start at one endpoint and go more than halfway across, make your arc above and below the line, and then go to the other endpoint and do the same. So that would be more like what you're familiar with, and really the way that makes sense to do it going forward. Alright, on the next page, construction to find the perpendicular bisector can be used to do three things: to bisect a segment, to locate a midpoint, and to create a set of perpendicular lines. That third thing is different from the first two. The first two have to do with equal segments. This one is more about making a right angle. So if we're given an indefinite line with no endpoints, like you see here in this diagram in exercise 3, and we're given a point on that line trying to make a perpendicular that runs through that point, what we want to do is basically bisect the line at that point. The problem is we don't have a bisector, or we don't have endpoints on that line yet. So the first thing that has to happen, and what it's telling you to do here in part A, is to put your compass point on A and make a circle of any size that goes through the line twice. So if I have my compass anchored here at A, I can make any size circle that crosses through the line twice. Where that circle hits the line is going to be equidistant from A, just by the way a radius works. So you know you have equal a segment that's surrounding point A equally. Alright, so from there, what we're going to say is now my segment that I'm bisecting is segment BC. I'm no longer interested in infinite line M. I'm more interested in segment BC. If I can bisect segment BC, it will run through A because A was defined to be the middle of that segment to begin with. Alright, so If I construct that perpendicular bisector, and you can see my football construction here, I will then be guaranteed that this runs perpendicular and equal through segment BC. So the takeaway from this is, if we need to make a perpendicular line run through a point on an infinite line, you must generate endpoints first by using your compass and going on either side. Once you have that, now you have a segment to bisect, and you can do it just like any other segment you've bisected. All right, down the bottom of this page, exercise 4 just shifts the point up off the line. So now we're bisecting through point A that is not lying on the line, and we're really going to do the same thing. We need to create a segment along infinite line N that we can then bisect. And the way we do that is to anchor our compass on our target point on A. Set your compass so that it could be any width you want as long as the arc crosses through the line twice, because I need to create a segment to bisect. So by setting it from A to B and running it through to C, I've created segment BC where both points are equidistant to my target point. Okay, so you can see that because of the radius that was used to form that. All right, and so to construct the perpendicular bisector, if I bisect segment BC, it will run through point A, and I know that because, remember, the perpendicular bisector is the collection of all points that are equidistant to the endpoints. So if my endpoints are now BC, and I run it through A, I know that that's on the perpendicular bisector. So if we have a point on a line or off of a line that we're trying to make a perpendicular from, we have to use that point to generate endpoints. Once those endpoints are generated, we bisect the segment that those endpoints form.